Yes, good evening good evening to everyone. Uh, I am Naren Vishwakarma, PhD scholar under PMRF scheme, working in the Department of Electrical Engineering at Indian Institute of Technology, Indore. So today I will be taking the week 6 of the Principle of Communication Systems Part 2. So we'll start with the first question. So consider the joint probabilities shown on the table corresponding to probability that x equal to si and y equal to rj. So find the entropy of y conditioned on x. Sorry, uh, it is x conditioned on y. That is x conditioned on y. Because previously we have already solved this question in the week 5 that the entropy h of y conditioned on x that we have previously solved in the week 5. And with the bigger expression now, this I will be solving using the properties of the conditional entropy. So you can also try this question. I will be giving 1 minute, 1 or 2 minute. You see the property and solve directly using the property. And previously using the formula we have already solved that. I'll show you. So try by yourself, then I will show the answer. Let's see the properties. Also, I'm writing the properties for you. I'm writing the property we can use here.
Sir, what is given is a joint probability, right?
Yes, sir. Joint probabilities. Like in the previous week, we have already solved this question. I will show you in the week 5, problem number 7. You remember that we have already solved the y given x using this formula, and these things we have already calculated in I think problem number 5. Yes, h of xy we have calculated, and already the value of alpha we have calculated. I think so. Yes, alpha was 1 by 24. So directly you can put that value and you can solve that. So the motive is that I will solve this question using some property. So let's see. So using some properties of conditional entropy, conditional entropy, that is h of y given x would be h of xy minus h of x, and for h of x given y it would be h of xy minus h of y. Clear? So we have to find the h of x given y. This one we have to find. Okay, so we need to calculate only h of xy and h of y. Previously we have calculated that alpha is 1 by 24, and h of y we have also calculated previously. H of y would be we are summing that is corresponding to this column will be corresponding to y, and this is corresponding to x, and we are when we are summing this one is I think 6 alpha, That is also 6 alpha, 6 alpha, 6 alpha. Here some 6 alpha, 6 alpha, and 6 alpha. So Hy we have already calculated in the previous week. So Hx and Hy was calculated as, I think yes, H of x is 2 bits, H of y is also 2. Okay. So H of y is 2, which is also equal to H of x, and H of xy we have to find the joint this one joint entropy, that is H of xy. So X of y I have written and calculated all the probabilities, and finding by using this formula H of xy, that is sigma ij Pij log 2 of 1 by Pij. Just remember this formula and we have calculated that things. So it has come out to be 3 plus half log 2 of 3. Okay. So it has came out to be of xy is 1 plus 3 plus half 3 plus half log 2 of 3. So clearly we can see that we can calculate h of xy as h of xy, that is 3 plus half log 2 of 3 minus h of y, which is 2. So it is coming out to be 1 plus half log 2 of 3. Similarly, you can calculate h of y by x. In the previous week, we have calculated this, but using that formula, that the lengthy formula. But here directly we can calculate h of x by and this one, and h of x is also equal to h of y. So clearly it will be equal to h of x plus y, that is 1 plus half log 2 of 3. I will show you what we have calculated. Problem number 7, h of y by x. So we have calculated by using this formula, clearly by this formula. Okay. So here we have arrived at the final expression 1 plus half log 2 of 3. That is same as that of this one 1 plus half log 2 of 3. And I told you in the last week that we will calculate h of x by y using the property. Okay, clear? So you can also calculate h of x by using this formula, also this formula, using this formula. Okay, but there will be change because previously it was y by y given x, but we need to calculate x given y. So here it will be probability of y equal to ri and h of x given y. I will write that. So here if you want to calculate, so the properly you can write like this: sigma j probability of y given rj into h of x given y equal to rj. Here this one, and solving this one, h of given y equal to rj, we have written that here, no, that yes, sigma of I probability of y probability of x equal to si given y equal to rj log 2 of probability x equal to si given y equal to rj. Clear? By using these two formulas, so you can also calculate, and using these properties directly we can obtain, if we have already obtained h of xy and h of x and y. Okay, so we can calculate the conditional probability, conditional entropy, sorry, entropies. Clear? So yes, any doubt in this problem? Have you understood what we have done in the last time and this time? Okay, so we'll move to the problem number 2. Yes, problem number 2. The levels of a 2-4 array PAM sources are SA equal to SB, that is minus 3 alpha, minus alpha, alpha, 3 alpha, with the probability that 3 alpha equal to 2 times of probability alpha, and 3 times of probability minus alpha, and 4 times probability minus 3 alpha. Now a COM source SQ is formed from the symbol x equal to A plus JB, where A and B are the symbols drawn independently from the sources X, SA and SB. Find the entropy of SQ, the source SQ, and find the conditional entropy of SA given SB. So what is in the question I will explain. So so it is given that two PAM sources are given. Okay, so that is nothing but alpha minus 3 alpha 3 alpha. That is one PAM source, 4 array PAM, 4 array PAM. That will be of SA, and the second one is SB. So we have already seen that the quantum signal is formed by two independently drawn PAM signal. Quantum signal can be formed by two independently drawn PAM sources. So one will be on the quadrature side and one will be on the in phase. And so these two are the 4 array PAMs. That is also 4 array PAM. Okay. Now, now we can previous in the previous question, week 5, we have also solved this type of question where I have given 8 symbols for a PAM source only. Okay, there were no Q source. Now the Q source is there. Now we have to find the entropy of HQ. Okay, so how can you find? Two sources are there, SA and SB. So it is simple because they are independent. So independently we can calculate the entropy of SA and entropy of SB and add them. Okay, so H of SQ would be H of SA plus H of SB. So calculate the entropy of SA and SB, and directly you can find the entropy of SQ. Okay, now try this one. In the previous week, we have also solved this type of problem where the probabilities were given and we have calculated the entropy of one source. I'm writing H of SA would be what is the entropy of HSA source HS? It is summation of I equal to 1 to 3 probability of psi log to that one by PR of psi. Clear? Now we have to find the probability of this. Probabilities are given, but in terms of each other. Absolute probabilities are not given. So you have to find that actually. What you can do for that. So one simple method here is you have to assume the probability of one symbol as like P. Now what is the probability of 3 alpha? That is 4 times of probability of minus 3 alpha, that is nothing but 4p. Similarly, what is the probability of minus alpha? That is nothing but probability of minus alpha is in terms of probability of minus 3 alpha, that is 4 by 3 probability of minus 3 alpha, because we have assumed only the probability of minus 3 alpha, that is 4 by 3 P. Now probability of alpha similarly. Yes. Is anyone? What is the probability of alpha in terms of P? Nothing but 2 times of probability of minus 3 alpha. That is nothing but 2. Now we have find the absolute probabilities, means probability of all these symbols we have obtained. Now we'll apply the total probability rule. That is nothing but total probability would be 1. So okay, total probability rule will be P plus 4P plus 4 by 3P plus 2P would be 1. So by solving this one, I'm not solving this. So you will solve and you will see that P is coming out to be 3 by 25. Okay, P is coming out to be 3 by 25. Now what? This one we use this equation. So it would be what? P, put here P, value of P here. Okay, so what it will be 3 by 25. It would be 12 by 25. Sorry. By putting the value of P, this equation you will get 12 by 25. 12 by 25. Here 4 by 3 into 3 by, so it will be 4 by 25. And here 2, that is 6 by 25. Okay, by using the total probability rule, we have find the now the probabilities. We are available with the probability. Now for SA, this is the probability. Similarly for SV, the probabilities are same. Okay, so the entropy of SA and entropy of SB are equal because the symbols are equal, na? 3 alpha, alpha, minus alpha, 3 alpha. The similar symbols are plotted in the quadrature phase, and these symbols are plotted in the in phase also. Same on the x-axis and y-axis. So now we have find all the probabilities. Now our work is very simple. We have to put the probabilities in this formula, and directly we can obtain the entropy. So by putting these values, I will write, and directly I will write the answer. I will first write the formula for that. That is log 2 of 1 upon 1 by 3, that is 25 by 3 plus 12 by 25 log 2 12 by 25. Okay, plus 6 by 25 log 2 of 25 by 6 plus, and one more is remaining, that is 4 by 25 log 2 of 25 by 4. Now solve this equation and you will see that the answer is 1.79. Clear? By solving this, you will get h of SA is 1.7. Similarly, h of SB is also equal to h of SA because same symbols are used with the same probability. So that is nothing but 1.79 bits. Clear? This is clear. Now, conditional entropy. This was simple. No. The total entropy. Total entropy of H of SQ, that is nothing but H of SA plus H of SB from this equation. From equation number 1, we will get 1.79 plus 1.79 2 times. It would be with answer. Solve this one. Calculated this one 1.79 into 2, that is 3.5. This is the final answer for part A. So for part A, this is the final answer. Now we'll see the part B. Find the conditional entropy. Okay, for SA and SB. Now, and one more thing, these two PAM signals are independent. Okay, these are independent. This property is used to calculate the conditional entropy, because it is not very simple to calculate, because we have to find by using the property also we need to find a few things. Okay, so here we go by the formula. So for the conditional entropy y given x, we have sigma I equal to 0 to n minus 1, probability that x equal to si into y, h of y given x equal to si. Yeah, and sigma I equal to 0 to n minus 1, probability x equal to si, and this can be expanded. This is the entropy. Expand that entropy, j equal to 0 to n minus 1, probability that y equal to rj given x equal to si log to 1 by rj given x equal to si. So why I'm writing this one? Because if the symbols are independent, this will be simplified. Okay, so let's say x and y are independent. If x and y are independent, then probability that x given y would be what? It will be seen as probability x comma y divided by probability of y. Or if they are independent, then this joint probability will be equal to, sorry, probability would be equal to probability of x multiplied with probability of y. Okay, so here we can directly write probability of x, probability of y would be probability of y, would be cancel out, and it is coming out probability of x only. Now these are independent, so here directly we can write from, so this will be used in this formula, so we can directly write h of y given x would be sigma I equal to 0 to m minus 1, probability x equal to si, summation j equal to 1 to n minus 1. Now probability of that is condition. Okay, now condition we can directly write x by y given probability of x only. So it is conditioned on y will be gone and it will be only equal to x. So here it would be equal to y only. So probability of y or I should write this one. So y equal to rj given x equal to si would be equal to, by using this property, it would be equal to probability y equal to rj. Okay, clear? So it would be log 1 by probability of y equal to rj. Clear? Now what?
Hello,
What is
sir.
next?
If x and y are independent,
Yes.
entropy of y conditioned and x is same as entropy of y, no?
Yes. That's what I am deriving directly.
Right, right. Okay, okay.
Okay. So it would be now you see that the variable j or the summation will be applied to this only, and I will be applied on this only because I is here only. So so this is what I equal to 0 to m minus 1 probability. So the sum of the all the probabilities will be 1. So this term would be 1 and this term would be, as the sir said, it would be the entropy of y. See that probability of y equal to rj log 1 by probability of y. That is nothing but the entropy of y only. So directly we can write this would be equal to h of y. H of y multiplied by 1, that is nothing but this. And h of x given y would be, if x and y are independent, then h of x. If they are independent, then this property will be applied, otherwise not. Okay, so in our question we have to find the conditional entropy of SA given SB. Okay, so we can write directly, we have to find in the part B, we have to find the entropy of SA given SB. Okay, SA given SB. SA given SB, it would be, now by using this property, it would be H of SA only. Clear? So that would be equal to, we have already found 1.7. Yeah. So I have derived this one. I think this is not given in the video lecture, so I have formed this one. So in the video lectures, it is only given these formulas. What I have explained here, that is given, but for independency, it was not given. So I have derived that one. It is simple only, and these are also given in the textbook also. Okay, this is clear. So we have already found these two parts, that is the entropy of HQ. The two sources are there, so that are independent. So we have directly sum the entropies of both the sources, and we can directly get the entropy, total entropy, and for the conditional entropy, that is S of A given S of B. So S of A, S of B are independent. So directly we can write it would be equal to H of SA, which is 1.71. Okay. So this
Sir, most of the problems I see are all independent only, no? In our examples, are there any
no,
non?
previous examples we have seen now where this independency was not there in this previous problem. Here,
Okay, okay,
here it was not there.
okay, sir.
Yes, in some problems it is given, but it is not. If it is not given, then we have not to assume that it is independent. But if they are independent, then in the question it is always given. Okay. Now consider a binary symmetric channel as shown below. So this binary symmetric channel is there where some probabilities are there. I hope this you have already gone through a binary symmetric channel BSC. So some probabilities are given, and we have also seen this in the video lectures also. So you have to calculate the conditional entropy H of x given y for alpha equal to 0.5 and p equal to 0.1, and for the same values you have to calculate the mutual information I of x comma y. Okay. To solve this is a simple question. If you can directly solve by using the formulas given in the video lectures, you can also solve, and you can also derive the few because it will not take much time. Yes, sir. Any doubt?
No, sir. Proceed to
Okay.
the next one. This is easy.
Okay. So let others solve this question while I am writing the probabilities. So I'm just writing the probabilities. I hope you also know that probability that R naught is received provided the S naught was transmitted is given as 1 minus P, which is also equal to when R1 is received provided S1 was transmitted. Similarly, probability of R1 given S naught is equal to probability of what R0 given S1. These probabilities. Okay. And the probability that probability of S naught that S is equal to S naught is alpha, and probability that X equal to S1 is 1 minus alpha. That is given in the question. Now you have to find the conditional entropy H of X given Y. So what is the formula for binary symmetric channel H of Y given X? What is the formula? Okay, so change that. You can also find X comma Y, but First we will find y given x. Both we can find, but try first y given. Yes, you know the answer. What is h of this one y given x? That is nothing but probability of x equal to s naught and h of y given x equal to s naught plus probability that x equal to s1 entropy of y given x equal to s1. Okay. So you can directly find this one. So h of y given x equal to s naught would be, so probabilities I will find, I will not directly write this one because it will be confusing. So this to calculate, to calculate this probability y given x of s naught, you have to calculate the probability of y equal to r naught s naught and probability of y given r1 s naught. Okay, so this will be 1 minus p, it will be p, okay, and corresponding to x equal to s1, also probability of y equal to s1 and probability of y equal to r1 given s1. So it would be also p and 1 minus p. So we can write here. So we can write that h of y by x given s naught would be h of p, and which is also equal to h of y given x equal to s1, which is also h of. Now what is the h of p? H of p is nothing but p log 1 by p plus 1 minus p log 2 1 minus p. So this is a notation for writing this entire thing. Means if h of some alpha is there, then you can write alpha log 2 of 1 by alpha plus 1 minus of alpha log 2 of 1 upon 1 minus alpha. That you can write for this notation. So sir has used this notation, so I am also using this one. So directly you can write h of y by x naught is h of p, and here y of x1 is also h of p. So we can solve this one. So h of y given x would be probability that x equal to x naught is alpha. So alpha h of p plus that would be 1 minus alpha h of p. So it would be alpha h of p will cancel out and you get h of p only. Clear? Which is nothing but this one. And p is given as 0.1. So solve this one. So I am solving now. So p is what? H of y given x will be h of p, that is nothing but p log 1 by p plus 1 minus p log 2 of 1 minus p. P is 0.1. Put p equal to 0.1 and solve. You will get, this is log 2. You will get 0.469. You can solve by yourself. I am not solving that. So you'll get h of y given. Now how to find h of x comma y? So here you can directly find by using h of y by x plus h of x. So it would be 1.469. Oh, sorry. H of x is remaining. Na? I have not find h of x. So h of x is simple only. H of x is nothing but sigma probability that x equal to si log 2 1 upon probability that x equal to si, where I equal to 0 and 1, S naught and S1. So probabilities are nothing but alpha and 1 minus alpha. So here also we can write h of alpha is nothing but alpha log 2 of 1 by alpha plus 1 minus alpha log 2 of 1 minus alpha, which is the probability of S1, because probability of S naught is alpha, so probability of S1 would be 1 minus alpha. Clear? So put the and the value of alpha is given as half. So when you put that value of alpha, and we have also seen that h of half is always 1. So you will try by yourself when you are putting h of half, then it will be always coming as 1. So from the above equation, so I've directly written that, so I will erase this one. So now I can directly write h of x comma y would be 0.469 plus 1, that is 1 point. Okay. And I'm giving you one more question. Find h of y. What is h of y? So further I will calculate, because for the part 2 mutual information, for mutual information we have to calculate h of y only. Okay. So what is the mutual information for this thing? So mutual information I of x y would be h of y minus h of y given x. Now we need to calculate h of y. So what will be the value of h of y? So h of y is nothing but summation probability Rj log to 1 by probability of Rj j equal to 0. Yes, have you solved this one? What is the probability of y, h of y? Can anyone tell me? We have, I think, seen in the video lecture also. But I will calculate this using the table. We have that table now. So this is some. Let's see, this is x and y. So that is R0, R1, S0, S1. So one of this column will represent the probability of Si, comma J. So here to find that we can use conditional probability. That is okay. Sorry. In conditional also we have some things and we do not have some quantities. So probability of Rj given Si into probability of Si. From here we can calculate. So probability of Rj given Si. So here probability of R naught given S naught. So for the first term I will calculate, and the rest of the things I will write directly. Probability of S naught. So probability of S naught is given, that is alpha, and R naught and S naught, that is 1 minus P and alpha. So it is here 1 minus P alpha. Similarly for R1 given S naught, that is R1 given S naught, that is P multiplied by probability of S naught, that is alpha. So I can write directly alpha here. So here also S1 R naught. So R naught and S1. So here the probability is P, and what will be there into S1, that is 1 minus alpha, 1 minus alpha, and here it would be probability of R1 given S1, that is nothing but R1 given S1 that is 1 minus P and probability of R1, oh sorry, S1 that is 1 minus alpha. So we have formed the table. Now directly we can calculate. Yes, anyone? How to calculate now? The marginal probabilities. Marginal probabilities. So by summing the columns along R0, so we'll get the probability of R0 and summing along R1, probability of R1. Here by summing across this one, we will get probability of S0 and probability of S1. So now we want only the probabilities of Rj, that is R0 and R1. So coming along this line, we'll get here we will get alpha plus P minus 2 alpha P. Is this correct? And by solving this one here, we will get 1 minus alpha minus P plus 2 alpha P. Clearly, I will write probability of R0 would be alpha plus P minus 2 alpha P, and probability of R1 would be 1 minus probability of R0, it is coming. So, which is also 1 minus P plus 2 alpha P. So, H of Y would be this one. You can directly H of alpha plus P minus 2 alpha P. So calculate this quantity. So calculate alpha plus P minus 2 alpha P. It would be alpha is 0.5 and P is 0.1. So it would be 0.5 only. And we know that H of 0.5 is or half is 1. So H of X and H of Y is 1 only. So the information. So finally we'll get our answer. I'm adding new slide. So we'll get the information h of x comma y. It would be h of y minus h of x and y, that is coming out to be 1 minus 0.649, that is nothing but 150. This is the mutual information. So yes, any doubt in this one? This is clear how to calculate the probabilities, marginal probabilities, and the joint probability of this binary symmetric channel using our previous table of the joint probabilities. Okay, is it clear? Yes, any doubt? Okay, so we'll proceed with the next question, problem number 4. So consider a source x with symbol x distributed with the exponential probability density function PDF of the source x. Now you have to find what is the differential entropy of x. Okay, so now we have moved to the continuous distribution or continuous probabilities for the differential entropy. So, if the random variable is discrete, then we will calculate the entropy, and if the this random variable x or the source x is continuously distributed with the exponential probability, that is continuous. So it is continuous PDF, continuous PDF. So we will encounter with differential entropy small of x, which is nothing but, similarly we can write, now the summation will be replaced by the integral, and the probabilities are replaced with the PDFs. So one difference is there. Here it is, the previously it was summation. You all see the summation is there, probabilities are there. Now here integral is there and PDFs are there. Formula is one and the same. So put this one here, PDF value here, solve this one and get done. Clear? So just solve this. So solve with me. So time is less, so I'm not giving much time. Now f of x is defined as this one for x greater than 0 and x less than 0. So limits would be 0 to infinity 1 by lambda e raised to power minus x by lambda log 2 of 1 by lambda is to power minus x by lambda. Or you can also write minus 1 by of lambda log of 2 1 by lambda so minus x by lambda. Clear? To dx. Now what can be done? So apply this property, take this as a and this as b and solve this. Log 2 of 1 by lambda e raised to power minus x by lambda can be written as log 2 1 by lambda plus log 2 of e raised to power minus x by lambda, and again this is exponential, so we have to get rid of that exponential in the log, so we can apply this property. Log of a raised to x can be written as log of x log of a with this one any base. So by solving this one you will get log 2 of lambda, let minus sign here, plus a log of e raised to e x by lambda log e raised to 2, and you can solve that minus log 2 of lambda plus this will be get is minus x by lambda here, and you can also write log 2 base e. Clear? So put this one, both minus sign are there and here minus sign is there, so it will be get cancelled. 0 to infinity 1 by lambda e raised to minus x by lambda log 2 of lambda plus x by lambda log 2 e dx. Now you can solve this integral. It is easy. I'm not solving, just writing the integrals for you, then you can solve by yourself. This is a constant, comes out of the integral 0 to infinity x into e raised to power minus x by lambda dx. Now by solving the integral, you will directly get log 2 of lambda plus this will be 1, this will be 1 and 1 no lambda. So lambda will be cancelled, you will get log 2 of lambda, and here by solving this one you will get 1 by lambda square log 2 is a constant, log 2 is a constant into lambda square which will be cancelled out here, and log 2 of lambda and log 2 of e both are there, so you can apply this property again. Log of a plus log of a plus log of b, it would be log 2 of lambda. Directly you get the differential entropy of x. Clear? I hope this will be clear. Directly you have to put the PDF in this formula, solve by yourself. Once again you will go through this one and you will clearly understand what is the other thing. The other part is the by solving the integral and using some log properties. Okay, so you can directly get this one. So try by yourself also. I'm not solving the integral. I'm just giving the concept what is used. Now problem number 5. So the differential entropy of a Gaussian random variable with zero mean and the variance of 2 will be. This is a very straightforward question. So now the differential entropy, the direct formula is also available. in the video lectures, but I urge you to solve this one. That is f of x, that is I have already written, but in the context of the Gaussian random variable, f of x would be, yes, 1 by 2 root of sigma square e raised to power minus x minus mu whole square by 2 sigma square, where mu is the mean and sigma is the variance of Gaussian random variable. Clear? So here the zero mean is given, but try to solve with mean also. Here, put that value here, the log, and apply some properties and simplification. So you will get the final form as, yes, anyone? What is the final formula for the Gaussian random variable, the entropy, differential entropy for the Gaussian random variable? What is that? Log 2 of 2 pi sigma square e, where sigma is the variance. It will not depend on the mean mu. Even if the mean is there, here it is given as 0, so you can put mu equal to 0 and solve this one. You will get. But if you put any value of mu also, you will get this one only. This expression you will get for any mean and the variance mean. And here the variance is given as 2. Sigma square is given 2. So directly put 4 pi and again apply the formula. So it will be half log 2 of 4 plus half log 2 of pi e, which would be, that will be 2 square, half is cancelled, so 1 plus half log 2. So what is the answer here? Option number, I think A is there, no? Okay, yes, A. So this is also a basic question, but yes, if you are not remembering the formula of Gaussian random variable, then you can always solve by using this one. This will take some time, but I urge you to go through this also and derive this one by yourself. Clear? It is clear? Okay, now last problem I think I can take, or directly I will show you the answer. So in this problem, AWGR channel is used
Sir,
where,
can you show the previous slide?
yes, yes, ma'am. Okay, the answer for this one,
Previous slide, sir. Previous problem.
this one.
Yes, yes. Thank you, sir.
Okay,
Finish, sir. Thank you. Fifth one.
okay. And this is clear. Problem number 5, have you noted? Okay, I will move to the problem number 6 now.
Noted, sir. Thank you.
Okay, okay. Now I will share the slides. Just understood the concept. That is 4 kilohertz. 4 kilohertz bandwidth and the noise power spectral density is eta by 2, that is 10 to the minus 12, 12 watts per hertz. Now the signal power required at the receiver 0.1 milliwatt. Calculate the capacity of this channel. Okay, so you need to calculate the capacity of this channel. So in the lectures also we have derived the Shannon's capacity, that is C is equal to half log 2 1 plus P by sigma square. So here P is the power, signal power, and this is the noise power. And this formula will give the capacity in bits per symbol. Bits per symbol, this we can also calculate, but here the bandwidth is available, so one more formula is there, W log 1 plus P by sigma square. This will give the capacity in bits per second, where W is the bandwidth, okay, where bandwidth is 2W, sorry, 2W is the bandwidth. Clear? So here bandwidth is given as 4 kilohertz. Okay, AW channel with the 4 kilohertz bandwidth. So it is given like that W W minus W. So the total bandwidth will be 2W, which is W is given. W is 4 kilohertz, that is 4000 hertz. 4000 hertz. And power spectral density PSD is given as eta by 2. Now, to calculate the power using the power spectral density, the total power P would be PSD into bandwidth, total bandwidth. That is twice of W into PSD. So it would be 2 times 4000 into 10 raised to power minus 12. Clear? So this will be P, and you know W is 4000 hertz. Now what is remaining? Sigma square. Sorry, one thing I have misplaced is this is the power, not the P noise power. Sorry, this is the noise power. That is the noise power. Okay, this is noise power. And the signal power P is given as the signal power is received at the receiver is 0.1 milliwatt. That is 10 raised to the minus 3 watt. So now by putting all these values in this formula or here, you can directly calculate this. That is 4000 into log 2 1 plus 0.1 into 10 raised to the minus 3 divided by 8000 into 10 raised to the minus 12. By solving this one, you will get 54.44 into 10 raised to the power 3 bits per second. Okay. So one thing you need to remember that the noise power will be equal to the PSD of the noise into the bandwidth, total bandwidth. This is the AWGN with 4 kilohertz bandwidth. So this is not the total bandwidth. This is the available in W. Okay, so total bandwidth will be twice of that. Okay. Yeah. So this sir has also discussed this in the video lecture also, where the band limited signal is like that, minus W and W, and total bandwidth is 2W. So here he has replaced 2W. So here 2W is replaced and half is there. So it is coming out to be W log 2 1 plus P by. Okay, so I hope you understand these problems and you will try yourself once again to get more clarity. Okay, so we'll stop here. Yes, thank you everyone.